Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello dear students, I hope you are all doing well. Welcome to another video from your channel, Easy Chemistry for All. This is Mr. Muad. And before we start, please put a like, subscribe, and share the channel with your friends so that many more students can benefit, hopefully, bidnillah, from these videos. This is the barcode to join the Telegram group where I post worksheets and the PowerPoints of the videos. So you can join if you did not join yet. You will join and I will approve your request after that, inshallah. So, in this video, we are in Module 18, or the chapter title Electrochemistry, الكيمياء الكهربائية. In lesson 1, voltaic cells, اللي هي الخلايا الفولتية. So this chapter depends on the previous chapter اللي هو redox reactions. Okay, so please revise redox reactions before you watch this video. Okay, we'll do some revisions of course, but you need to know like details about oxidation and reduction. So these are the learning objectives. So we want to describe a way to obtain electrical energy from a redox reaction. So from the title electrochemistry, يعني في electricity, في كهرباء من الكيمياء. So we want to describe how we can get electrical energy from a redox reaction, identify the parts of a voltaic cell and explain how each part operates, calculate the cell potentials and determine the spontaneity of redox reactions. So we'll be focusing on redox reactions, okay? Alright. This is part 1. So this is what we will do in part 1, guys, okay? You can read it, define electrochemistry, describe electrochemical cell while specifying the types and the components of voltaic or galvanic cells, okay? We'll go through this in detail, inshallah. So we want to answer what is electrochemistry and how do voltaic cells harness energy from chemical reactions. كيف نستخلص طاقة كهربائية من التفاعلات الكيميائية؟ شو التفاعلات الكيميائية اللي عندها علاقة بالطاقة الكهربائية؟ هي redox reactions. Okay. Remember oxidation meaning the loss of electrons or an increase in oxidation number. Reduction يعني gaining of electrons, فقد الإلكترونات. Okay. So have a look here, guys. Imagine you have a reaction like this. What are the two half reactions? So this is a redox reaction, صح? يعني you can notice that here oxidation happens and here reduction happens, صح؟ لأن هنا الشحنة زادت وفي الCU plus 2 الشحنة صارت صفر. Again هذا اللي هو الفيديو السابق اللي هو balancing redox reactions, okay? فيديو الدرس الثاني من الشابتر السابق. So you can watch it if you want. So we can see that the two half reactions that make up this process are Zn gives me Zn plus 2 electrons, because electrons are lost, because the charge is plus 2, so you lose 2 electrons, and the reduction half, okay? So you gain 2 electrons. Cu plus 2 gains 2 electrons and becomes Cu. تمام؟ الحين there is a transfer of electrons. Remember redox reactions, there is a transfer of electrons. قاعدة تنتقل, صح? So how can we generate an electrical current? تيار كهربائي. So electricity is generated from the movement of what? Of charge or electrons, right? Okay. So what do we mean by electrochemistry? Electrochemistry is the study of the redox processes by which chemical energy is converted into electrical energy and vice versa. فالكيمياء الكهربائية مهتمة بدراسة الريدوكس reactions. Okay? اللي من خلالها الطاقة الكيميائية تتحول لطاقة كهربائية أو الطاقة الكهربائية تتحول إلى طاقة كيميائية. vice versa معناها العكس صحيح. Okay, so this is electrochemistry. That's why we are focusing on redox reactions. Okay, so redox reactions involve the transfer of electrons from the species that is oxidized to the species that is reduced. Okay, So we already know that, all right, from the previous chapter. So imagine I have a copper wire, right? And imagine oxidation happens here and reduction happens here. What is flowing in the wire? Electrons, right? Electrons are flowing from the oxidation part لأن this one lose electrons and this one will gain electrons. So when we join a wire of zinc and Cu strips اللي هم هاي القطع المعدنية, it provides a pathway for the flow of electrons. يعني في هني مجال لانتقال الإلكترونات لأن الواير صح؟ But it's not forever. The pathway is not complete. Electron transfer is still not possible. Why? Ions build up upon electrons. Because remember, the Zn will become Zn plus 2 وراح يترسب فوق هذا. And the Cu will become Cu plus 2 becomes Cu. Okay? So there's a buildup of ions on the strips. And this is a problem. Okay? كيف نحل هاي مشكلة الأيونات؟ The ions build up on electrons. On electrodes, we use something that helps the ions transfer action. Okay? And this is what we are going to see. The way to fix it is to use a salt bridge. Okay? So before we go through a salt bridge, electrochemical cell, تعريف electrochemical cell أو الخلية الكهروكيميائية is an apparatus يعني جهاز that uses a redox reaction to produce electrical energy or uses electrical energy to cause a chemical reaction. يعني هو جهاز يا إما يستخدم الطاقة الكهربائية في صنع تفاعل كيميائي أو يستخدم التفاعل الكيميائي لتكوين طاقة كهربائية. We have two types. We have electrolytic cells and we have voltaic cells. In this lesson, we will be focused on voltaic cells. In this lesson, our main focus is on voltaic cells. Sorry. Okay. So a voltaic cell is a type of electrochemical cell that converts chemical energy into electrical. يعني إذا السيل تحول الطاقة الكيميائية لطاقة كهربائية نسميها voltaic cell. And the redox reaction is spontaneous. We will see why later. Okay. الحين, what is a salt bridge? A salt bridge is a pathway to allow the passage of ions from one side to another so that ions do not build up on the electrodes. Can you see this thing here? This is the salt bridge. يعني نحط فيها salt ionic compound, نحط فيها ايونات. Okay. شو معنى هالكلام؟ If we go back ما كان في salt bridge هني صح؟ So the pathway is not complete and ions build up on the electrodes. When we put the salt bridge, now the electrons are going from the oxidation to the reduction part. وهاي المعادلات اللي تحت صح؟ لأن هذا oxidation يفقد الإلكترونات، الإلكترونات تنتقل تروح لوين؟ للreduction half part اللي هو يكتسبهم because reduction is gaining of electrons. This is possible because of the salt bridge. So the salt bridge and the wire provide an unbroken pathway for electric charge to flow. And the redox reaction provides energy to light the bulb. يعني عشان تشغل المصباح. فأنا عندي قاعد يحصل شو تفاعلات كيميائية redox reactions. لما حطيت السولت بريدج وحطيت الواير الإلكترونات وهي تتحرك قدرت أني أكون طاقة كهربائية. وهذا تعريف الفولتايك سيل. إنه أستخدم الكيميكال إنرجي أو التفاعل الكيميائي اللي هو الريدوكس تحت هني عشان أكون طاقة كهربائية اللي إحنا شفناها هني إنه المصباح يشتغل. Okay? Alright. What is an electrolytic cell? Now, electrolytic cell is the inverse, عكس voltaic cell. It's a type of electrochemical cell that converts now electrical energy into chemical energy. تحول الطاقة الكهربائية إلى طاقة كيميائية by a non-spontaneous redox reaction. Okay, this is where electrolysis happens, and this is just an image to show you that you have a battery action. يعني نحط طاقة كهربائية، والطاقة الكهربائية هاي تخلي التفاعل يحصل. في الفولتايك التفاعل اللي قاعد يحصل هو اللي يكون طاقة كهربائية. في الإلكتروليتيك سيلز نحط باتري، فالطاقة الكهربائية هي اللي تخلي التفاعل يحصل. That's the difference between both. Okay. So, which is a pathway to allow the passage of ions from one side to another side of a redox reactions? تكلمنا عليه صح؟ Which one? Salt bridge صح؟ We saw it here. This is the salt bridge. It allows the pathway for ions. Which is an apparatus that uses redox reaction to produce electrical energy or uses electrical energy to cause a chemical reaction. يعني اللي هو الالكتروليتيك سيل والفولتايك سيل الاثنيناتهم نوعين من انواع الالكتروكيميكال cells. Okay. Which is a type of electrochemical cell that converts chemical energy into electrical energy by a spontaneous redox reaction. Well done. It's the voltaic cell اللي هي احنا بنركز عليها في هذا الدرس. Okay. So, an electrochemical cell consists of two parts, and these two parts called half cells. تتذكرون الريدوكس reactions كنا نقول انه في two half reactions صح؟ واحد حق الاكسيديشن وواحد حق الريدكشن. نفس الشيء هنا في الالكتروكيميكال سيلز في two parts، لان بارت قاعد يحصل فيه الاكسيديشن والبارت الثاني قاعد يحصل فيه ريدكشن. We call them half cells, in which the separation of oxidation, in which the separate oxidation and reduction reactions take place. الحين في تسميات احنا لازم نتعلمها. اوكي. الالكترود where oxidation takes place او اللي هو الهاف cell where the oxidation takes place is called the anode. اوكي. يعني لو انا عندي هنا قاعد يحصل oxidation بسمي هذا البارت الانود. اوكي. And the cathode is the electrode where the reduction occurs. يعني إذا هذا الجزء هو اللي يحصل فيه reduction, I will call it cathode. Right? And we already talked about the salt bridge, so you can stop the video and read about it. Okay? So electrons flow from the wire from the oxidation half. صح اللي هو الانود، لان احنا قلنا يعني اذا قال لك الاكسيديشن هاف سيل او هاف رياكشن اللي هو الانود because we said that where oxidation happens that's called the anode. All right, to the cathode. All right, so basically everything is shown here, guys. Okay, so this part here is called the anode because this is where oxidation happens. And the electrons flow from the anode to the cathode. ليش؟ لأن الكاثود هو اللي reduction يحصل فيه، يعني يكتسب إلكترونات. Okay. So this is very important, and this is the direction of electron flow, and this is the direction of the current flow. And we always put a solution where the cathode is. يعني مثلا imagine you have Cu here, this is Cu, so this solution contains the cathode's ion, يعني this solution will contain Cu plus 2. If this was Zn, the solution contains the Cu plus 2 and a negative ion, okay, like for example SO4 minus 2. Same thing here. This one will contain the anode's ion, which is Zn plus 2. Okay, let me just show you. Yeah, as you can see here, this is the solution that contains the ions. Okay, هالمحاليل that contains the ions. All right. Okay, Now we go to part 2. So now we know what's a voltaic cell. We know the meaning of the cathode. We know the meaning of the anode and everything. So this is what we want to do now. We want to write the oxidation and reduction half reactions occurring at the cathode and the anode. Remember, الكاثود اللي هو يحصل فيه شو؟ reduction. إذا تريدوا تتذكروها هني في حرف السي والكاثود فيه حرف السي عشان ما تتلخبطوا. So الكاثود reduction, الانود oxidation. And we'll describe the standard hydrogen electrode which we will go through inshallah. So now we go to part 2, guys, and part 2 is actually focused on writing the oxidation and reduction half reactions occurring at the cathode and the anode. Okay, remember الكاثود اللي هو شو يحصل فيه؟ reduction. كيف نتذكرها؟ عندنا السي هني والسي هني. So reduction cathode والانود يحصل فيه الاكسيديشن. And we will learn about the standard hydrogen electrode and the standard electrode potential. This is just the voltage, okay? So we'll go through it inshallah in the next few slides. Now, how can we write the oxidation and reduction half reactions? We already know that from the previous video, okay? From the previous video. So, we want to write the half reactions of the cathode and the anode. And you have this equation here. So this is what we want to do. So basically you have the anode, which oxidation happens, and the cathode, which reduction happens, right? So look here, واحد من هذيلا will be oxidized and the other will be reduced. So Al becomes Al plus 3, يعني oxidation. So you come here and write 2Al gives me 2Al plus 3. And the plus 2 becomes 0, so reduction. So 3Sn plus 2 gives me 3Sn plus 2 becomes 3Sn. Now, did we finish? No, we need to show the electrons. لازم نبين الإلكترونات. تذكروا these are redox reactions. فهذا oxidation يعني فقد إلكترونات. كيف نعرف كم فقد من إلكترون؟ نشوف الشحنة هني. كم الشحنة؟ 2 ضرب بلس 3 بلس 6. والشحنة هني 0. فلازم الستة تصير نفسها 0. So we'll just add 6 electrons here. Because if we add 6 electrons, this will be minus 6. Alright? So basically, plus 6 and minus 6 is 0 والحين تساوي الشحنات. And the electrons are in the products. الإلكترونات موجودة في البرودكت. يعني oxidation يعني فقدت الإلكترونات. هني العكس. عندنا الشحنة هني plus 6 and here 0. So how many electrons do we add? We add 6 electrons. Here minus 6 plus 6 and minus 6 is 0 والحين تساوي. So this is the reduction half reaction and this is the oxidation half reaction. لأن reduction نسميه cathode لأن oxidation نسميه anode. So that's exactly what it is. Now if they ask you about what is the cathode, it will be the element, الميتال. يعني no charge. ما في شحنة. Okay? مش معناها انه هذا هو الكاثود، لا، الكاثود هو اللي ما يكون فيه تشارج. لانه تذكروا remember this, these are metals. هذا هو الكاثود والانود. هذا مثلا كان شو Zn وهذا كان Cu. فلما يسألك على الكاثود والانود لازم نحط اسم المعدن او رمز المعدن بدون الشحنة. Okay? So that's very important for you to remember. Okay, and the anode is going to be Al. ليش؟ لأنه oxidation وهذا reduction. And this is the reaction at the cathode اللي حليناه قبل شوي. And this is the reaction at the anode اللي حليناه قبل شوي. Okay. So what is the name of the two parts of an electrochemical cell? Separate oxidation and reduction reactions take place. Two parts, so half cells. Now, because electric charge can flow between the 2 points, or any 2 points, or can flow between 2 points when the difference in electrical potential أو voltage exists. يعني أنا إذا عندي نقطة A وعندي نقطة B، عشان يكون في تيار كهربائي لازم إنه الفولتج A ناقص الفولتج B ما تكون صفر، يعني ما يكون متساويين الفولتج أو البوتنشال، لازم يكون في اختلاف في الفولتج عشان التيار يقدر يتحرك. هذا من الفيزيكس كلاس. Okay. So a volt is a unit used to measure cell potential. يعني cell potential هو نفسه الفولتج يا جماعة. Okay. It's the same as the voltage from your physics class. And it's the force from the difference in electrical potential between the two electrodes اللي هو الانود والكاثود. Okay. So how do we measure the voltage in a voltaic cell? Okay. So this has to be voltaic cell. And this is the same question. هذا هو نفس السؤال لأنه cell potential أو E naught is the same as the voltage in physics, which is delta V. So delta V is the same as the cell potential. Okay, نفس الشيء. So before we learn how to measure it, we need to learn some terminologies. لازم نتعلم بعض الأساسيات. First of all, the formula for cell potential. So the formula of the cell potential أو voltage تساوي الفولتج حق الكاثود reduction ناقص الفولتج حق الانود اللي هو oxidation. In other words, it is the potential of the cathode minus the voltage or potential of the anode. هذا كيف نطلع ال voltage of the cell, of the whole cell. Right? Because we have a note here, we call it the standard. So the standard potential of a cell is the standard potential of the reduction half cell اللي هو هاي minus هذا هو minus the standard potential of the oxidation half cell اللي هو هاي. Right? Now, where do we find these values for the cathode and the anode? Where do we find them? There's actually a table for that, but what we are going to do now, we will learn من وين اجوا هذه الvalues. Okay? So, we are still learning about terminologies. So the tendency of a substance to gain electrons is called a reduction potential. يعني reduction potential اللي هي مدى قابلية المادة اللي هي تكتسب إلكترونات، لأنه reduction معناها إلكترونات، اكتساب إلكترونات. When two half reactions are coupled, the voltage generated corresponds to the difference in potential between the half reactions, which we talked about. صح؟ اللي هي delta V. It's like the difference in voltage that you took in your physics class. Okay. We are going to have a look here about this. This is called the standard hydrogen electrode. We will learn about it in few slides. Okay. And actually, two reactions happen here. Hydrogen is oxidized, and at the same time it is reduced. And the voltage of this cell is actually 0. Okay? The voltage of this cell is 0. This is like reference point. Okay? Alright. So which is the tendency of a substance to gain electrons? It is called the reduction potential. اللي هي شفناها هنا. Okay? Which we saw it here. Now, what is the standard electron potential? اللي هي E naught. What is that? So the standard electrode potential is the potential or voltage developed by a metal or other material immersed in an electrolyte solution relative to the potential of the hydrogen electrode, which is 0. يعني, for example, I have zinc here, right? I will connect it to another cell. It has here Pt, but here we have hydrogen. Okay, so إذا حسبنا الديفرنس ما بين الZn والهيدروجين or the hydrogen and Zn, okay, hydrogen and Zn, because here reduction will happen and here oxidation will happen. احنا قلنا reduction minus oxidation, it will give me a number. This number is going to be the standard electrode potential for zinc, لأنه ال E of hydrogen is actually 0. Remember? The E naught for hydrogen is 0. So whatever value I get, it is the value of this part here, not the hydrogen. وهذا هو اللي مشروح هنا. يعني الستاندرد electrode potential ال E naught هو الفولتج حق هذا الالكترود لما نحطه في خلية مع الهيدروجين. So compared to the hydrogen, which is 0. Okay? Why is the standard potential of hydrogen 0? Because it is used as the reference point of the scale. يعني عندنا هيدروجين وفي فوقها قيم وفي تحتها قيم، هني 0. Okay? So the standard hydrogen electrode, so ال S وال H وال E اختصارهم شي، اللي هو هذا this part which I told you we'll talk about, consists of a small sheet of platinum immersed in a hydrochloric acid solution. يعني عندنا هني شفتوا هذا الجزء، هذا platinum electrode، وهني عندنا محلول acid اللي هو HCl. Okay, and it has these values 1 molar and the pressure is 1 atm and the temperature is 25. Because the pressure is 1 atm and the temperature is 25 بسبب هذيلا كلمة standard اجت، لأن standard معناها الضغط 1 atm و temperature 25 degrees Celsius. So the standard hydrogen electrode أو She is the standard against which all other reduction potentials are measured. It is like 0.0 on a scale. يعني عشان أنا أعرف ال standard potential for Cu مثلا reduction potential أو voltage of Cu, I put it with hydrogen and that's how I can find it because hydrogen is 0. Okay, نفس ما شرحت هني. Okay, and it is 0. The standard potential is 0. So the standard reduction potential of hydrogen is 0, and the good thing about She or the standard hydrogen electrode is that it can be both oxidation half or reduction half depending on the half cell to which it's connected. يعني مثلا إذا أنا حطيت الZn مع الهيدروجين، هذا ZN, and here I have hydrogen and here Zn. So this Zn here is the oxidation part and the hydrogen is the reduction part. إذا حطيت الهيدروجين مع Cu، الحين Cu بتكون reduction part والهيدروجين بيكون oxidation part. يعني دائما أقدر أحسب الفولتج أو البوتنشال of the other plates or the other elements when I put it with hydrogen، لأنه الهيدروجين مرة يقدر يكون oxidation ومرة يقدر يكون reduction. Okay, this is what we mean by this part. And remember, to calculate the E of the cell, it's going to be, for example here إذا جينا نحسب ال E of the cell equals E reduction minus E oxidation، صح؟ We will see it in the next slide actually. So what about the standard potential or E naught of the other elements? How can we calculate it؟ يعني احنا نعرف انه الهيدروجين is 0. So by comparing it to 0، يعني شو نسوي؟ مثلا احنا جبنا هني Cu copper, right? And this is the She. هذا فولت متر، جهاز يقيس لك الفولتج. فاحنا نعرف انه هني reduction وهني oxidation. فهني في قيمة موجودة صح؟ هاي القيمة شو المعادلة حقتها؟ ال E naught of the cell equals E reduction minus E naught oxidation. وين شفنا احنا هذا؟ So it's here, remember? This is the equation for the cell potential or the voltage. قلت لكم هي نفسها الفولتج صح؟ So it will be E naught reduction minus الأكسيديشن هو الهيدروجين زيرو، يعني هي نفسها ال E naught reduction، يعني القيمة اللي قاعدة تطلع هني هي القيمة أو ال E potential for Cu لأن الهيدروجين زيرو. And same thing with zinc. Okay, same thing with zinc. So the E naught of the cell is لاحظوا إن الزنك هني الحين oxidation والهيدروجين هو الريدكشن. It will be E naught reduction minus E naught oxidation. هذه الصفر لأن هي حقة الهيدروجين، فالرقم اللي بيطلع لي بالماينس، عشان شي هني الرقم هني بالماينس بتلاحظوا، وهذا الرقم اللي يطلع هو نفسه الرقم حق مين؟ حق الزنك، لأن الهيدروجين is zero. And like scientists did a lot of experiments، يعني كل مرة كانوا يخلوا الهيدروجين ويغيروا العنصر، مرة يحطوا Cu مرة يحطوا Zn ويحسبون، قاعدوا يحسبوا سووا كثير من العناصر like Li, calcium, Na, Mg and so on, and they calculated the standard reduction potentials. And now we have all these values which you will be using يعني في المعادلة في البارت الثالث لما نيجي نحسب إن شاء الله reduction minus E naught oxidation راح نستخدم هاي القيم تكون معطاة في الامتحان. Okay, to use it. And now we go to part 3, and in this part we will learn how to write the cell notation and the overall chemical equation of a redox reaction, and we will learn how to calculate the E naught of the cell اللي قلت لكم عليها قبل شوي. Okay, let's have a look at this voltaic cell. So imagine that we have a voltaic cell. Okay, this is where the oxidation happened. This is the oxidation half cell. So this is the anode, and this is where the reduction half cell happens. So this is the cathode. Okay, so to write the overall reaction, we need to make sure that the number of electrons is the same in both. So electrons here is 2, here is 2, so we delete them, and then we add المتفاعلات مع بعض. So the reactants together, H2 and Cu plus 2. We put the arrow and then النواتج or the products together, 2H plus and Cu. So we already saw this in the last chapter when we were adding or balancing redox equations. Okay, when we have an oxidation half and the reduction half, same number of electrons, just add the two equations together, add the reactants together and the products together. Now, how can we write the cell notation? So how can I know where is the cathode, where is the anode, where is the oxidation cell and the reduction half cell? It's very lengthy to write these like this, okay? So instead, what we will be doing, this overall reaction can be written like this. So we put the oxidation half cell here, okay? And the reduction half cell on the right. So we start with the oxidation half cell. What is the oxidation half cell? This is the reactant. هذا المتفاعل صح? We put H2. Then we put a slash. Okay, or this line here, and then we put the product which is H plus. Then we add two lines to show that they are connected, like this is the first half, then two lines. Then we go to the reduction equation and then we put the reactant here, then line, and then the product here. So this is called, or this one is called the cell notation. So to write the cell notation, we separate the oxidation half cell or the anode and the reduction half cell or the cathode, we separate them by two lines. We write the oxidation half cell by starting with the reactant and then the product H plus, we separate them by a line, then two lines, then the reactant of reduction, then a line, and then the product of the reduction. We call this the cell notation. Okay? So these two lines are like the salt bridge connecting the two half cells. So you can try and solve this question now. You have two equations. One is oxidation, one is reduction. So this one is going to be oxidation, and this one is reduction, right? So write the overall equation, like add them together. Before you add them, you need to make sure that they have the same number of electrons. Here we have 2 electrons, here we have 3. So you need to multiply this equation by 3 and this equation by 2. So now, when you multiply that, the number of electrons here is going to be 6, and the number of electrons here is going to be 6. Here you will have 3, here you will have 3, here you will have 2, here you will have 2. So electrons, they are deleted, and now we have 3Cd, okay, plus 2Au plus 3 المتفاعلات مع بعض, as you can see. And then in the products you will have 3Cd plus 2 plus 2Au اللي هم النواتج here together. Okay, you see them? So this is the overall reaction. Now to write the cell notation, I told you need to put 2 lines. First separate them, then 1 line here, 1 line here. And now you start, like in this place, you put the oxidation half. And here you put the reduction half. So what is oxidation? It's the first one. So you put Cd and then Cd plus 2 متفاعل بعدين الناتج, and then here you put المتفاعل first, so Au plus 3 and then Au, because it's the product in here. So this is the oxidation half and the reduction half, and this is the cell notation. So this is what we covered here. Okay, this one is just another example. Now, what about the formula of the cell potential? So to calculate the cell potential, okay, to calculate the cell potential, here's what we need to do. We need to find the E naught reduction minus E naught oxidation, or E naught of the cathode minus E naught of the anode. Okay, these are values that they will give it to you in the exam, and then you will use them. So very important for you to understand, if E naught cell is positive, if the E naught of the cell is positive, meaning the E cell here is bigger than 0, the reaction is spontaneous. If E naught cell is negative, it means the reaction is non-spontaneous. So you need to remember that. Alright? For example, here the E naught is positive. Look at the voltage, it's bigger than 0, and the voltage here is less than 0. So this one is spontaneous, this one is non-spontaneous. So what are the rules to calculate E naught of the cell? So all half reactions are given as reduction half reactions. So these E values or standard reduction potentials are for the reactions or the half reactions, okay? So for this half reaction, this is the voltage. For this half reaction, this is the voltage, and so on. All right? Now, what else? When a half reaction is multiplied by an integer, E naught remains the same. For example, in this reaction, this is the E naught, right? If multiplied by 2, E naught does not change. If I multiply it by 4, E naught does not change. So these do not change, all right? Finally, if E naught cell is positive, the reaction is spontaneous. The reaction will be non-spontaneous if E naught of the cell is negative. Okay? So, here's an example. So this problem says the following reduction half reactions represent the half cells of a voltaic cell. So So these are the half cells of a voltaic cell. Okay. What they want you to do is to do the following. Determine the overall cell reaction. Okay. The standard cell potential, which is E naught cell, and describe the cell using the cell notation. So basically, this is what you don't know, the overall cell reaction, E naught of the cell, and the cell notation. So we want three things from here, okay? And this is given to you, okay? This will be given to you. So the reduction, the standard reduction potentials for each half cell is given to you here, okay?
Hello.
So, as I told you, these values will be given to you in the exam. So you'll use them to find E naught cell. So the problem is which one is going to be reduction, which one is going to be oxidation. How can we know? So basically, the half reaction with the higher E naught is reduced. So which one has the higher or bigger E naught? It's this one, right? So this one is going to be reduced. So this one is going to go here, and this one is going to be oxidized, so it will go here. So the half reaction with the higher E naught is reduced. يعني between those two, this one, okay, I2 plus 2E gives me 2I minus. This one will be reduced. So this is the cathode. Okay? So this one will be the reduction half cell. This one will be the oxidation half cell. So basically, to write the overall equation here, okay, you just add both of them, but just for you to understand, we shouldn't write this. This will not be the oxidation half cell. The oxidation half cell will be Fe plus, sorry, Fe gives me Fe plus 2 plus 2E. And now we will add this one and this one. Electrons will go away, and then you will have I2 and Fe, and then the arrow comes, and then you will have 2I minus and Fe plus 2, because this is oxidation, okay? So we need to reverse this one to make it oxidation. And this is the overall reaction. Now let's calculate the standard cell potential. So it's E reduction minus E oxidation, okay? So basically we have the values here which are already taken from the table given to you. طبعا كيف عرفنا انه هاي reduction؟ لانه الاي نوت تبعها اكبر من الثاني. So it will be plus 0.536 minus 0.447, and our answer will be positive 0.983 volts. And the final thing, we need to describe the cell notation. So as you know, we write the oxidation half or anode at the left. This is the anode because it's oxidation, Fe and Fe plus 2. And then we write the cathode, which is the reduction, okay, together. So we write it here, and then we connect them. So this one is anode, or the oxidation half cell. This one is the cathode, or the reduction half cell. كيف نعرف نكتبهم؟ قلنا دائما هي reactant product. So reactant product, and here reactant product. So reactant product. Okay? And that's the end. So is the reaction spontaneous or not? The reaction is spontaneous because E naught of the cell is positive. Now, for the rest of the slides, you have some problems similar to this one that we just solved now. So what you can do is use these values and try to answer the questions 1 and 2. So this will be used in 1, and these equations will be used in 2. And then after solving them, you can check your solutions here, okay? And make sure you got the correct answer. Okay. So now, for the last part that we need to explain here, we have some main points, okay? So in the standard potential, in the standard potential or the E values, the E note values, if you have a higher standard potential or a bigger E note, okay, you will be a stronger oxidizing agent. If you have a bigger E note, you will be a stronger oxidizing agent, meaning you will be reduced. Remember when I told you that because E note is positive and it's big, it will be reduction and the smaller one will be oxidation? So this is what's said here. Now, if E note is lower, if it becomes lower, it means you are a stronger reducing agent. يعني كل ما قلت ال E note كل ما it's easier for you to be oxidized. كل ما زادت ال E note كل ما it's easier for you to be reduced. What does that mean? It means you are a strong oxidizing agent. What does that mean? It means you are a stronger reducing agent. So low E note means stronger reducing agent. Higher E note means stronger oxidizing agent. And that's the end. So you can watch this video again if you want, solve the questions, and yeah, that's the end of lesson 1. There are some other questions here which you need to solve, okay? And the answers are found here. So you just need to find the E note of the cell, and you need to use table 1 in the book, okay? What will table 1 contain? It will contain these half reactions with these values so that you use to calculate the E note of the cell. Yeah, and that's it. If you have any questions, please let me know.